Okay, so what we are going to start is question problems of NLM, and we completed till over here friction and all these kind of topics, isn't it? We dealt with that. We did some means the more concept of friction, like little bit extra problems and all. We'll do in with this question series. Is that okay? Okay, so we completed constraint motion. One part of the constraint motion is left, and that is base constraint, which we'll do later. Is that clear or not? So let us start with the problems of NLM, and you will have only 1 minute to solve each question, not more than that. Is that clear? Okay, and then we'll move ahead. So let us start the question number one. Okay, so the question starts like a bullet of mass 20 gram has initial speed of 1 meter per second just before it starts penetrating a mud wall of thickness 20 centimeter. If the wall offers a mean resistance of 2.5 into 10 to the power of minus 2 newtons, the speed of the bullet after emerging from other side of the wall is close to. Yeah. So the question, like this way you have to go, means you have to first think of the approach, then apply the concept, and then do it fast within less than 1 minute to 2 minutes. Okay. So I'll once again explain the question. A bullet of mass 20 gram has an initial speed of 1 meter per second. Just before it starts penetrating a word wall of thickness 20 centimeter, the wall offers a resistance. Okay. Wow, that is a good question. The speed of the bullet after emerging from the other side of the wall is. So tell me, what can this be? Hmm, hmm, hmm. Okay, so should I give you some hint? Okay, so look over here. What is actually happening? I have a wall. Let us just take this wall and I just fire a bullet over here. Is that clear? Now this bullet goes inside it. It hits the boundary. It hits this wall. Then it emerges out. Now when it emerges out, basically what it is saying that the velocity will change because this surface over here is providing some kind of resistance, isn't it? So when it provides some resistance, then definitely the velocity will change. So consider this velocity to be u initial velocity, and then consider this to be final velocity as v. Are you able to get me or not? Okay. Now, if there is a change in velocity, means as I know, if there is a resistance, there will be deceleration. The acceleration will be in this direction, isn't it? Resistance basically. Are you able to get me or not? So the resistance will be along this side. So the velocity will decrease. Now, how the velocity will decrease? Because I am going to provide some kind of retardation over here, isn't it? So let us calculate our retardation. How much is that? We know that, yeah, basically retardation will be provided. Retardation is done on the bullet, but it is provided by the wall or not. Now, as over here it is given that the mean force, the force which is providing that resistance is given. So can we get the retardation over there or not? Because the force is already mentioned over here. So retardation will be what? Force by mass, the force of the wall by mass m, isn't it? What is the force of wall? It is given 2.5 into 10 to the power of minus 2. And mass is given how much? 20 grams. So 20 into 10 to the power of minus 3. Is that clear or not? So basically, how much is this? I think you will get it as, it is going to come as, I'll write in terms of acceleration. So if it is acceleration, it is minus of retardation. So this will come as minus 5 by 4 meter per second square. Is that clear? Now, as I got this, if I got my acceleration, one thing is also given to you, that the thickness of the wall is given, isn't it? How much is the thickness? So that is 20 into 10 to the power of minus 2 meters, isn't it? Or minus 1? Minus 1 meter, isn't it? Basically, it is given centimeter. Are you able to get me or not? Why? Minus 2 or minus 1? Ah, okay. I think it is minus 2. Ah, millicentimeter. Oh, okay, correct, correct. I forgot. So it's minus 2. So basically, I got my thickness. So that is my particular displacement of the wall. If I can apply v square is equal to u square plus 2as, then I can get my final velocity over here on. So what I will get? U square is 1 meter per second. So 1 square plus 2. Acceleration is minus 5 by 4. And thickness is how much? 20 into 10 to the power of minus 2. Isn't it? So how much is that? V square is equal to 1 minus 1 plus basically 4 5s are 20, 5 2s are 10, and that is how much? 10 into 10 to the power of minus 2. So this is minus 0.5, isn't it? So V is equal to how much? Root under 1 by 2 meter per second, basically, which will root under 1 by 2 is almost around 0.7. Are you able to get me or not? Is that correct? Mix of NLM plus kinematics. You have to solve like that way. Now the questions will be totally mixed. Okay. So we go to next question. Any kind of doubt? We have to be a little bit fast. Okay. Try this question. Be fast, be specific, and try it fast. I think this question has came in. I think it is of J means something. Some year is there. So tell me, a block of mass 5 kg is first pushed in case A, then pulled by force of 20 newtons. Means this is my block of mass. How much kgs? 5 kgs. Both are pulled by sometimes force of 20 and then this force of 20. Making angle 30 degree with the horizontal as shown in the figures. The coefficient of friction between the floor. Okay, so the surface is rough. Both are rough, which is in which mu is equal to how much? 0.2. The difference between the acceleration in the case B and the case A will be. बताओ बहुत अच्छा क्वेश्चन दिया मीन्स इट्स टू मच गुड क्वेश्चन जल्दी बताओ 1 minute टाइम ही था हम्म both the cases 30 and 30 yeah okay let us first resolve this let us see if this is 20 and this is 30 so can I just write that one of the force along this side will be 20 cos 30 and another force will be this one downwards which will be how much 20 sin 30 isn't it similarly over here this will be 20 cos 30 and this will be 20 sine 30, isn't it? Whatever happens, the normal will act upwards. So normal is upwards for both the cases. Yeah, one guy actually has. Huh. You'll have to tell. Yes. Actually, there are some guys who have joined online and they have told the answer correct. Basically, it is 0.8. Okay. So now look over here. Do it fast, Risty, I'll kill you. So this is 5G. And this will be how much also? 5G. Isn't it, Risty? And the friction will act opposite of both of them. Are you able to get me or not? Now, when the body starts to run, it is saying that the acceleration is already present. So this will be kinetic friction. Yes. So in first case, let's suppose this is kinetic friction 1 and this is kinetic friction 2. Basically, the equation will be what? Let's suppose this is acceleration in B and this is acceleration in how much? A. So in first case, the acceleration will be what? The pulling force is 20 cos 30 minus kinetic friction 1 is equal to my mass 5 kg into acceleration A1. Yeah, F, isn't it? Second equation, this will be 20 cos 30 minus Fk2, and that is 5 into acceleration B. Are you able to get me or not? Now the task is there that what is the frictions in both the cases. So if I calculate Fk1 over here, since friction of kinetic friction is given as mu into normal, consider this as normal N1 and this as normal N2. So this is in normal N1, mu is 0.2. But here the normal will be exactly equal to 5G minus 20 sine 30 or not? Yes, so that is 20 sine 30. And here the normal in second case will be what? Mu into N2, that will be 0.2. And here what will happen? It will be added basically. You see that both of the forces are in downward direction. So this will be 5G plus 20 sine 30, isn't it? So when you just take that case, when you just do this, so if this is okay, I'm considering this as acceleration A. So if I'll do that acceleration of A minus acceleration of B, if I just put in these values in these two equations, what I'm going to get is at 0.8 meter per second square. Is that clear or not? Can you do that or not at least? So you replace the value of root 3 now? Yeah, almost around 1.7 you replace it. Okay, take the approximations basically. Okay, that will provide you a good thing, that will provide you a edge over this. Okay, okay, can we move ahead? Okay, do this next question. What is the maximum value of F such that the block shown in the arrangement does not move? That's a good one. बताओ जल्दी से. Friction is given, mu is given 1 by 2 root 3. Yeah, you have to think of that inclination basically. No, you see the case. If I see basically, if this is my surface and I try to pull this block, okay, okay, this is my mass M. Now the force applied is kind of just whenever these kind of things you get, just make the force go forward. Then the force is applied like this way or not? Yes. Basically, this is the direction of force, isn't it? Now, if you look at that angle as 60, what you will find that this angle is also how much? 60. So it is asking that if this is force F, okay, this force should be maximum. Okay, what it is? It's showing down only. You see that? That's the inclination. But that is same only. Okay, we can extend it. So mass is given to you, that is root 3 kg, and mu is given to you 1 by 2 root 3. You have to tell me that what can be the maximum value of force such that the body will not move. Yeah, 20. Yes, it is correct. थिंक अच्छा देखो, एक बात बताओ, इस फोर्स के दो कंपोनेंट होंगे। हाँ, और इधर कितना होगा? एफ साइन 60। एम जी नीचे होगा क्या? नॉर्मल ऊपर। हाँ, एंड फ्रिक्शन इधर, है ना? अच्छा, अगर हमें बॉडी को मूव नहीं कराना है तो ये जो फ्रिक्शन की वैल्यू है वो क्या मेरा एफ कॉस 60 से बड़ा या इक्वल होना चाहिए, है कि नहीं? यस। या बेसिकली विच फ्रिक्शन? मैक्सिमम फ्रिक्शन ना, बिकॉज आई वांट मैक्सिमम फोर्स। सिंपल सी बात है, हमें क्या चाहिए? मैक्सिमम फोर्स चाहिए ना। तो जो फ्रिक्शन लगना चाहिए, मतलब जो बॉडी की टेंडेंसी होनी चाहिए वो कितनी लगनी चाहिए? मैक्सिमम फोर्स पे हमें फ्रिक्शन एफ मैक्स लगना चाहिए, है ना? मतलब सिंपल सी बात है, अगर बॉडी को मूव करा रहे हैं तो हम किसी टेंडेंसी क्या है कि अगर फोर्स की वैल्यू, अगर अप्लाइड फोर्स की वैल्यू मैक्सिमम फोर्स से ज्यादा है तभी बॉडी मूव करता है। तो अगर हमें ये फोर्स की वैल्यू वो मैक्सिमम चाहिए जिसके लिए बॉडी मूव ही ना करे, तो क्या वो एफ मैक्स के बराबर या उससे कम होना चाहिए, है कि नहीं? तो बेसिकली एफ मैक्स इज व्हाट? म्यू इनटू नॉर्मल, दैट शुड बी ग्रेटर देन एफ cos 60, isn't it? Mu is how much? 1 by 2 root 3. Normal is mg. Mg is how much? Root 3 into 10. Root 3z plus f sine 60. Basically, this is my normal. That must be greater than f cos 60. Are you able to get me or not? Which is f by, yeah. So this is g by 2 plus how much is this? Sine 60 is root 3 by 2. So this is f by 4. Yeah. So basically, this comes as what? This will come as g by 2, this is g by 4, so f must be less than or equal to twice g, which means f must be less than or equal to 20 newtons. Is that clear? So what's your answer? 20 newtons. Yeah, let us solve this next question. Insect crawls up a hemisphere surface very slowly. अच्छा, मैंने तुम्हें बताया था ना very slowly का मतलब क्या होता है, कैसे मूव कर रहा है? Yeah, the word very slowly means that the particle is moving with constant velocity. Means the acceleration is how much? Acceleration is how much? Acceleration is 0. That's the meaning of very slowly word. Okay. नहीं, सर्कुलर मोशन का क्वेश्चन नहीं है। अच्छा से बनाओ, बन जाएगा। इट्स टू इजी, इट्स टू इजी। Two minutes are over. This is my mass M on the circular track, isn't it? Think. We'll take up a circle like this over here. जल्दी से बनाओ, you have very less time left. अच्छा ध्यान से देखो, एक बात बताओ, अगर ये बेसिकली वर्टिकल के साथ कितना एंगल बना रहा है, अल्फा, ये एंगल कितना है? जब पार्टिकल, अच्छा जो चीटा है वो ऊपर चढ़ रहा है ना, theta is, yes, the answer is correct. Cot alpha is equal to 3. Some guys are solving very fast on YouTube, man. I don't know how they are solving. They're very good. Awesome. They are my students basically, Shruti, you know. Srishti. They are. What? They are my student over here only, okay? So look over here. So this is mass M. This is making angle alpha with the vertical, isn't it? अच्छा, ये अल्फा की वैल्यू क्या है? मैक्सिमम है, मतलब इसके ऊपर पार्टिकल जा ही नहीं सकता है कि नहीं? लेकिन टेंडेंसी क्या है, ऊपर जाने की ही है ना। तो अब ध्यान देखो, अब सोचो जरा, जो नॉर्मल लगेगा, अगर ये मास एम है तो इसकी वेट कहाँ लगेगी? नीचे, एम जी, है ना। अच्छा, ऊपर क्या लगेगा? नॉर्मल। तो ध्यान से देखो, अगर बॉडी को यहां से देखूं तो बॉडी के ऊपर फ्रिक्शन कहाँ लगना चाहिए? ऊपर या नीचे? एक बात तो हमें मालूम है कि जो फ्रिक्शन लगेगी, दैट विल एक्ट along द डायरेक्शन ऑफ tangents, isn't it? Yes. So where that friction should be? Is it upwards or downwards? It should be upwards, because the at when alpha is maximum, the body has tendency to go where? Downwards. Are you able to get me or not? Very, very good. The friction will act where? In the upward direction. Is that clear or not? हाँ, तो फ्रिक्शन ऊपर लगा, ऊपर। अच्छा, जो ये एंगल अल्फा है, तो ये भी एंगल कितना? अल्फा। तो एम जी का दो कॉम्पोनेंट आएगा, एक एम जी कॉस अल्फा, और इधर कितना आएगा? एम जी बेसिकली। अब ध्यान से देखो, यहाँ पे बेसिकली बोल रहा है कि जो इस पॉइंट पे बॉडी है, बॉडी की टेंडेंसी तुरंत चेंज हो गई ना, सीधा ऊपर जो जा रहा था अभी कहाँ जा रहा है? नीचे। तो बॉडी के ऊपर अगर बॉडी वहां से गिरे नहीं तो क्या करेगा? जो फ्रिक्शन लगेगा वो कितना लगेगा? मैक्सिमम फ्रिक्शन लगेगा, है कि नहीं? सो क्या पूछ रहा है कि द हेमिस्फेरिकल द मैक्सिमम वैल्यू ऑफ अल्फा सच दैट द बॉडी विल नॉट फॉल। तो सिंपल सी बात है, एफ मैक्स की जो वैल्यू होनी चाहिए वो कैसी होनी चाहिए? एम जी साइन अल्फा से बड़ी होनी चाहिए, इजंट इट? सो एफ मैक्स है कितना? म्यू इंटू नॉर्मल। नॉर्मल है कितना? एम जी कॉस, दैट शुड बी ग्रेटर देन एम जी साइन अल्फा, है कि नहीं? एम जी कैंसिल, एंड व्हाट आई गॉट? basically mu into cot alpha greater than equal to 1. Mu की value है 1/3, so this implies cot alpha should be greater than or equal to how much? 3. Are you able to get me or not? मजा आया? चलो फिर एक और क्वेश्चन में बढ़े आगे। चलो ये क्वेश्चन बनाओ, दिस इज एन ऑसम क्वेश्चन। गुड श्रेयस, गुड। No, do not take it as 3. That's a question of J. Do not take it as 3. Yes, let us work with decibels only. That's why they have given this question. Yes, 3 kg will make it simple, but see, all the terms are 2.9, 1.9, 9.8. Okay, make it 3 or 2. Okay, make it just 3 kg. And this has, and take G as 10 meter per second square. Okay, so what it is saying that each length is of 1 meters, isn't it? This length is also how much? 1 meter long. What it is asking that the upper wire has negligible mass. इसके पास मास की वैल्यू कितनी है? जीरो. लेकिन नीचे वाला जो है ना उसके ऊपर मास प्रेजेंट है. इस थ्रेड में क्या प्रेजेंट है? मास which is how much? Uh, the lower wire has a uniform mass of 0.2 kg per meter. So it's not mass given over here. It's linear mass density given over here, isn't it? So lambda is equal to 0.2 kg per meter. The question is, the whole system blocks, wires and support have an upward acceleration of 0.2 meter per second square. The whole system is going with an acceleration of 0.2 meter per second square. Then find the tension at the midpoint of lower wire. Find the tension at the midpoint of the upper wire. Yeah. Socho, Socho. It's a very, very good question. I have done this part. I have made you understand how to consider the tension of upper and lower wires. Yeah, actually, what was the concept? Let's suppose if I have a block and yeah, and then there was a thread of mass m. If I try to pull this with force F, then just do one thing. You know that the equation will be same. The whole system will be accelerated by some acceleration, isn't it? The trick was to cut the part from where it is asking. Let's suppose this is m, and the length which is asking is l dash. So considering this mass m dash is there, so this will be supported by a tension T, and then we can write that tension T is equal to nothing but m plus m dash into acceleration, common acceleration AC. यही था ना क्वेश्चन, यही था ना ट्रिक. बस. So you follow that trick. So if I look over here, if I see the first question, I'm sorry, if I see the first question, okay, question part A. So when I look at the first question, then it is asking the midpoint of the lower wire. यहाँ पे पूछ रहा है ना, यही क्वेश्चन है. अगर ध्यान से देखा जाए तो इसकी वेट एक होगी 2G. इसकी वेट कितनी होगी? 3G. इसके लिए एक टेंशन क्या लगेगा? T1. इसका एक रिएक्शन आएगा ना T1 का, है ना? और यहाँ पे कितना लगेगा टेंशन? T2. Is that clear? That is all my equations, isn't it? But it is asking at the midpoint of the lower wire. So what will be the connection? The midpoint of the lower wire will divide the wire into two halves, and then it will be attached with the block of how much kgs? 2 kg, isn't it? Now, if it is a midpoint, lambda is given as 0.2 kg. You know that mass is equal to lambda into length L, isn't it? So, how much is my mass present in this half of the section? That is, m is equal to lambda, which is 0.2, and length is how much? 1 meter. So, if it is half, then it will be 1 by 2 or not. So mass is how much? 0.1 kg. So, yeah. So this part has 0.1 kg. And then the equation will be same now. That I will just divide. So this will be my tension T dash, or you can call it as T1 dash. Yes. And that T1 dash, and this whole system has a common acceleration AC given over here, which is how much? 0.2 meter per second square. Are you able to get me or not? Uh, uh, uh. Okay. So if I just see that, then the weight will be what? 2z over here. And 0.1 g weight will be how much? Its also weight will be 0.1 g. So what will be the equation? Pulling force T1 dash minus opposing force 0.1 g minus 2g, and that will be equal to total mass which is getting accelerated, which is 0.1 plus 2 into acceleration is how much? It is given, that is 0.2. Is that clear or not? Put this equation, you will get the answer. That's all. ठीक है. Are you able to get me? So simply you just put these values. What you will get as T1 dash is equal to how much? I think it will come as 20 newtons. Almost not 20 newtons, approximately 20, since we change the values. It will come as between 20 and 20. Yeah, between 19 newton to 20. Yeah, there will be some simple value. Do the calculation for the part B. Find the tension in the midpoint of upper wire. You have to find over here. Mhm. Again, apply the concept of pulling force. It will give you a very great idea. Means it will just be done. It can be just done within less than 2 minutes or something like that. If you use the concept of pulling force. Yeah. Once again, if I just look over here, the no, its mass is zero. Yeah. Now you got the thing. Its mass is basically zero. So no need to consider. No need to consider basically. So this is how much? 2.9 kg. हाँ, एक मैं बता रहा हूँ. और ये क्या है? 1.9. अच्छा, ध्यान से सोचो. तो इसके ऊपर कुछ अलग टेंशन लगेगा. मान लो कितना है? T2. अब मासलेस है तो इसके ऊपर चारों तरफ बराबर लगेगा. कितना लगेगा? T2 ही लगेगा. इज दैट क्लियर और नॉट? इन सबके पास कॉमन एक्सेलरेशन है. हाउ मच इज दैट? 0.2. अब ध्यान से सोचा जाए तो यहाँ पे एक टेंशन जो लगता है T1, और यहाँ पे एक टेंशन लगेगा T1, इन दोनों का तो कैंसिल हो जाएगा ना. T1 T1 dash at the ends of the wire, at least at the ends of the wire they will be uniform, isn't it? So this is 1.9 g and this is how much? 2.9 g. So what will be your equation? Basically T2 minus 1.9 g minus 2.9 g will be, yeah, that will be your equation, no? Why T1? Once again I'm saying you, this T1 and T1 will get cancelled over here or not? Huh? But yeah, one thing will be also there. Since the thread has some mass, thread has mass, no? Mass of thread is how much? Yeah, 0.2 kg. So this will be once again minus 0.2 z. Are you able to get me? Yeah. So this will behave like if you just see the upper rope, it will see that मतलब ऐसा लगेगा कि ये तीनों को ऊपर खींच रहा है. T1 तो कैंसिल हो जाएगा ना भाई. तो बचेगा क्या? Mass of the block, mass of the thread, and mass of the particular another block. That should be exactly equal to the total mass of the system, which is 1.9 plus 2.9 plus 0.2 with common acceleration AC. है कि नहीं? तो T2 की वैल्यू कितनी आई? Just do it. This is going to be 5. This is almost 5 into common acceleration AC is given 0.2 plus this is 5 into 10. Almost this will become as how much? 50. This is how much? If you just take G as 10, so this is 50 plus 1, 51 Newton. Is that clear or not? ठीक है. हरदम एक ही कॉन्सेप्ट यूज करना है. एकदम ये बात याद रखो. इफ यू हैव मेनी ब्लॉक सिस्टम, इफ यू हैव एनी काइंड ऑफ सिस्टम, एंड इफ acceleration is mentioned to you, if masses are there, this thread has also some mass. Yeah, mass of A, mass of B, mass of C. And if you are pulling by some kind of force such that it has a common acceleration AC, then the equation will be, look over there. If I see the opposing forces, this is MAG, this is MCG. For the thread, it will be MBG. And these tensions, since in the thread I have told you, the thread is inextensible in nature, isn't it? So if it is inextensible, the net force on the thread will must become how much? Always zero. Is that clear? But if it has mass, then definitely it is there that at some points different tensions will appear. But if it is, I'm considering for the whole thread, the net force on the whole thread is always how much? Zero due to its inextensible nature. Okay. So the equation will become what? The pulling force minus the force which are opposing, that is MAG minus MBG minus MCG, and that will be how many masses it is accelerating, that is 3 masses MA plus MB plus MC into its common acceleration AC. Always you have to use these equations. Are you able to get me or not? Can we move to next question? Okay, do this. This is just similar like previous question. Correct, pendulum wala thing hi. A mass of 10 kg is suspended vertically by a rope from the roof. When a horizontal force is applied on the mass, the ropes get deviated at an angle of 45 degree at the roof point. Then what you have to do? If the suspended mass is at equilibrium, the magnitude of force applied is. That deviated the pendulum by an angle of 45 degree from its equilibrium point. Consider this force to be constant, this applied force to be constant, then only you can get the answer. 1 minute time you have. Yes, it's correct. 100 Newton. Very good, awesome. Hey, you do it fast, man. Srishti done? This is a J Men's question of 2019. So much easy they are giving in J's these days. अच्छा एक बात बताओ सुनो. Yeah, T is equal to definitely no. It will not be mg cos 45. Think over once again. तुमने एक चीज गलत किया. अच्छा ये पेंडुलम था. इसके ऊपर मैंने क्या किया? फोर्स अप्लाई किया. अभी ये पेंडुलम कैसा हो गया? ऐसा at an angle of how much degrees? 45. ध्यान से देखो तो बोल रहा है कि if the suspended mass is at equilibrium, किस पॉइंट पे? तो 45 डिग्री पे ये कैसा है? इक्विलिब्रियम पे है ना? तो look over there, the force is still acting over here or not, isn't it? Yes, and the tension is acting where? Upwards, obviously. Now, if the tension is acting upwards, this tension will have how many components? Two components? Yeah. So this is what mg, and this is once again 45. So t cos 45 और इधर क्या होगा? T sin 45. Why? There is an external force acting over here or not? So if you will balance that, then if you take mg cos 45, then you'll have to take the force component also or not? F sin 45. If you balance towards the tension T, then you have two forces over here, isn't it? Got it? So if there is an equilibrium, I told you that day, if there is an equilibrium, you have to always see the upward force balances with the downward force, right force balances with the left force. That's all. No need to take other components in any other direction. If it is an equilibrium, take upward force is equal to downwards. Just resolve using these directions only, either in upward or downward, or right or left. That will save your time, right or not? Means whenever you get the problem of equilibrium, just resolve all the forces in only two direction. If it is a vertical case, upward, downward, right and left. Is that clear? ठीक है तो ध्यान से देखो if it is yeah, so basically I'll write t cos 45 is equal to how much mg, and t sin 45 is equal to capital F, isn't it? Take the ratio of that if we write. So this becomes sin, that is tan 45 is equal to F by mg. Tan 40 is 1, so F is equal to mg, which is how much? 100 newtons. Because I told you you have to resolve in upward and downward, right and left. If you look over there, two forces are in upward and right and downward direction. Only one force which was inclined over here. So I just take the component of this t along the upward direction and the right direction because I know that for downward forces. That's all because I know that the upward force will be downward for the equilibrium case and right will be equal to the left for the equilibrium case. Apart from that, anything else is not possible. Is that clear? Because see, other things are also possible. You can resolve in that in the direction of tension, but that will make your question tedious because you do not know the F value, and still you do not know that tension. Yes, you can resolve it, but it will come very like it will be a very tedious way. Like if I just resolve, see that if this is tension T, if this is mg, this is F, then you try to see if you'll resolve along this direction. It will be mg if that angle is theta, this angle will be theta, this will be 90 minus theta. So how many components you will have to take first, and you need to also get the value of tension T also. Okay. The another method to do this is by the Lami's theorem. We call it as what? Lami's theorem. See that this was my tension T, isn't it? This is my force F, and this is my mg. Three forces were acting, and this angle was given as 45. So you can just resolve it. You can see that this angle is how much? 90. So Lami's theorem says what? The first force, tension T, divided by the opposite angle you have to consider. So sine this will become how much? 90 degree. That will be exactly equal to force F divided by this opposite angle. If you see over here, this is 90 and this is 45. So this will be F by sine 90 plus 45. And that is exactly equal to mg by the opposite angle sine 90 plus 45. But remember that this equation, these opposite equations are only applied if the system is in equilibrium. Lami's theorem is only, yeah. So you can apply this equation and then you can still get the answers. Nice. Can we move ahead? Let's move to next question. Think. They are not representing anything. You think of that. They are just dotted lines. A block of mass m is raised under the action. This is the whole block of mass m. Okay. Just try to imagine in that sense. Which of the following statement is incorrect? Think. Uh-huh. A and B is true. Yeah, A and B is true. That's so correct. Mm-hmm. F will not produce torque. That's the Shreyas answer. Shreyas is Acha, I have actually it's a question of rotational motion, but we'll see that. I'll tell you one thing about this question. It's this is something related with toppling. Okay, there is a very nice discussion when this is something related with toppling. When I will teach rotational, then you will get to know. Okay, but right now let us see that. अब क्वेश्चन आ गया तो बनाने की कोशिश करते हैं ना. देखो हम अगर फोर्स लगाएं और बॉडी कैसा इक्विलिब्रियम में है ना, तो हमें मालूम है कि सेंटर ऑफ मास से एक फोर्स लगेगी जिसका नाम है mg नीचे लगेगा है ना, और नॉर्मल जो फ्रिक्शन होता है वो ऊपर लगेगा विच विल ट्राई टू, या बेसिकली अब ध्यान से सोचा जाए, अब इस क्वेश्चन को अच्छे से समझो. अगर ब्लॉक के ऊपर तुमने फोर्स लगाया तो हम क्या सोचते हैं कि जो नॉर्मल लगेगा ये सेंटर ऑफ मास इसका है, तो नॉर्मल यहां से लगना चाहिए, बेसिकली यहां से लगना चाहिए. इज दैट करेक्ट? नहीं, एक्चुअली में द आंसर इज नो. बिकॉज यू थिंक, तुमने वो कभी देखा है क्या, कभी सोचा है जो जैसे दीवार पे तुम, मैं बता रहा हूँ जैसे मान लो अगर तुम्हारे पास एक दीवार है, दीवार पे अगर स्टिकर लगा दिया, क्या लगा दिया, तो जब दीवार से स्टिकर हटाओ, जब मतलब वो ऑटोमेटिकली जब छोड़ना है स्टार्ट करेगा तो देखना वो ऊपर से छोड़ता है, नीचे से नहीं छोड़ता है कि नहीं. ये ऐसा क्यों हो रहा है? क्योंकि जो mg जो है वो क्या क्रिएट कर रहा है, टॉर्क क्रिएट कर रहा है इस पॉइंट के थ्रू. अगर ये पॉइंट को हम माने तो ये पॉइंट के थ्रू ये टॉर्क जनरेट करने की कोशिश कर रहा है या नहीं कर रहा? कैसे नहीं जनरेट करेगा? व्हाट इज टॉर्क? टॉर्क इज आर क्रॉस एफ और नॉट. यस. तो अगर मान लो ये पॉइंट पी है, तो इस पॉइंट के थ्रू ये हो गया एक रेडियस और इसके थ्रू mg लगा, तो ये एक क्लॉक सॉरी एंटी क्लॉकवाइज टॉर्क जनरेट करेगा ना. Yes. So that will try to rotate the object. Now, when it is trying to rotate the object, I'll make you understand this thing in much more greater sense in rotational dynamics. Just right now, what I'm telling you is just try to understand that this mg is trying to create a torque. When the mg is trying to create a torque, the normal does not act at the center of mass, but it gets shifted. क्या हो जाता है वो normal? नीचे की ओर शिफ्ट हो जाता है. Are you able to get me or not? क्योंकि देखो, ध्यान से देखो, तो जो mg का टॉर्क है वो कैसा है? एंटी क्लॉकवाइज. लेकिन जो नॉर्मल का जो टॉर्क है वो कैसा हो जाता है? क्लॉकवाइज, सो दैट इट कैन बैलेंस द ऑब्जेक्ट ऑन द वॉल. आर यू एबल टू गेट मी और नॉट? Okay. So the normal gets shifted downwards so as to balance the object perfectly. Is that clear or not? So पहली बात हरदम याद रखना, if I am pressing a block on the wall, the normal does not act at the center of mass. It acts somewhere in the shifted direction, in the downward direction. Is that clear or not? Why it, if it goes up the अच्छा ध्यान से देखो, ये क्या है? रेडियस. अगर ये मान लो सेंटर है ना, चलो मैं पहले ब्लॉक ड्रॉ करता हूँ. ये ब्लॉक हो गया. ठीक, यहाँ पे एक mg है, तो mg का क्लॉक टॉर्क कैसा है? एंटी क्लॉकवाइज है ना. ठीक, अब ध्यान से सोचो, अगर नॉर्मल को मैंने ऊपर शिफ्ट कर दिया तो फिर क्या होगा? सोच जरा, टॉर्क लग कहाँ रहा है? नीचे की ओर लग रहा है, सेंटर ऑफ मास के थ्रू नीचे ही लग रहा है ना. ठीक है. लेकिन अगर मान लो, मैं सेंटर को ध्यान में रख के सोच रहा, ठीक है ना, तो टॉर्क कहाँ लगा? नीचे. बेसिकली अगर नॉर्मल ऊपर शिफ्ट हुआ, देखो बॉडी की टेंडेंसी कहाँ है जाने की? रोटेट करने की नीचे की ओर. तो अगर तुमने नॉर्मल ऊपर लगा दिया तो फिर भी बॉडी की टेंडेंसी कहाँ रही? नीचे जाने की ओर. लेकिन अगर तुमने नॉर्मल नीचे की ओर शिफ्ट कर दिया, तो ध्यान से देखो, जो टॉर्क लगेगा इस रेडियस के थ्रू, ये बेसिकली कैसा है? ऊपर की ओर. सो इसलिए नीचे शिफ्ट होता है. आर एबल टू गेट मी और नॉट? Okay, so it will not shift upwards because the torque is still anti-clockwise through the center of mass. But if I just shift it downwards, the torque becomes which side? Okay, that was clockwise basically. तब से मैं गलत बोल रहा हूँ. ठीक है, तो mg का है clockwise. ऊपर शिफ्ट किया तो भी कैसा रहेगा? clockwise. अगर नीचे शिफ्ट किया तो कैसा रहेगा? एंटी क्लॉकवाइज. तो इसीलिए नॉर्मल कहाँ शिफ्ट हुआ? नीचे. बेसिकली दिस कम्स अंडर द कॉन्सेप्ट ऑफ टॉपलिंग. आर एबल टू गेट मी और नॉट? या विल डील विद दैट इन अ ग्रेटर सेंस. तो ध्यान से देखा जाए तो मेरा सिंपल सी बात है, फोर्स एट द सेंटर ऑफ मास. तो फोर्स जो होगा वो तो टॉर्क जनरेट ही नहीं करेगा थ्रू द सेंटर ऑफ मास, बट नॉर्मल, the question is the normal is generating a torque over here or not? Why? So as to make the body stable over here. So which statement is incorrect? The normal will not produce the torque. Option D is incorrect. Is that clear? मेरी बात समझ में आई? चलो आगे बढ़े क्या? ठीक है, let's do this question. This is an advanced question. Wow, awesome. Hell awesome. Not only awesome, hell awesome, basically. ये थोड़ा बहुत रोटेशन से रिलेटेड है, आई थिंक सो. द कोफिशिएंट ऑफ फ्रिक्शन, द लैडर इज अबाउट टू स्लिप. ठीक है, द लैडर इज अबाउट टू स्लिप हो गया ना. सोचो जरा क्या होना चाहिए. इट्स रिलेटेड विथ हर रोटेशन लिटिल बिट. ओके, थिंक ऑफ द रोटेशनल. थोड़ा सा रोटेशन सोचोगे तो बन जाएगा. अच्छा, मैं हिंट दे देता हूँ. जो बॉडी है, बॉडी के ऊपर नॉर्मल हरदम याद रखना कहाँ लगेगा. इस केस में, लैडर केस में कैसा लगता है? परपेंडिकुलर फ्रॉम द सरफेस. अच्छा, अब अगर स्लिप होगा तो ये वाली एंड लेफ्ट की ओर जाएगी. तो फ्रिक्स करेक्ट. तो फ्रिक्शन कहाँ लगेगा? पीछे. इसके लिए कहाँ लगेगा? राइट, राइट. और ऊपर वाली एंड कहाँ आएगी? नीचे. तो फ्रिक्शन कहाँ लगेगा इसके लिए? इज दैट क्लियर और नॉट? हाँ, तो इस कॉन्सेप्ट को सोच के बनाओ, बन जाएगा. consider it to be n2, consider it to be n1 बोल रहा है। अच्छा एक बात होता इस क्वेश्चन में देखो क्या लिखा हुआ है, द लैडर इज अबाउट टू स्लीप। स्लीप हो रहा है क्या? अबाउट, अबाउट जैसे ही वर्ड अबाउट आया तो फ्रिक्शन कौन सा कैसा लगना चाहिए? एफ मैक्स। तो दोनों तरफ कैसा लग रहा है? मान लो ये F1 है तो F1 मैक्सिमम लगेगा, और यहाँ पे F2 है तो F2 भी कैसा लगेगा? मैक्सिमम। इज दैट क्लियर और नॉट? अब ध्यान से देखो तो क्या सेंटर से मेरा वेट mg लगेगा? जरूर ना? सोचो, बनाओ। इट्स इजी इजी। What it is asking? You think what it is asking? If mu1 and yeah, first means you have to establish a relation of n2 and n1 with respect to mu1 and mu2. Then you can only get the answers. Okay. No, no, no. You can, yeah, basically you can say like that. N2 plus F1 max is equal to how much? mg. And system equilibrium में कहाँ है? About to slip हो रहा है ना? But still, since it is not slipping, you can write like that. But yeah, so N1 बराबर F2 max, isn't it? But what you are going to write, basically, the answer will not come from this. या अब वो कैसे बनाते हैं? तो थ्रू द टॉर्क इक्वेशन। कैसे थ्रू बनाते हैं? बेसिकली अगर ध्यान से सोचा जाए, अगर अबाउट टू स्लिप होने वाला है तो बॉडी ऐसे रोटेट करेगी, है ना? ठीक। अब मान लो अगर अगर बॉडी को स्लिप नहीं कराना है, अभी मतलब बॉडी क्या है? अबाउट टू स्लिप है, तो कॉन्सेप्ट तो सेम ही है कि अगर मैं ये पॉइंट बी मानता हूं तो टॉर्क थ्रू बी मस्ट बी इक्वल टू हाउ मच? जीरो। Okay, so 1 minute. See, what is the question? That if the ladder is about to slip, so simple. If the ladder is about to slip, it's not slipping. But the if it is not slipping, the torque at the point B must be equal to zero or not. Then only it will not slip. Yes. So if I want to write the torque about B, the first thing arises that how to write that. But before that, as you told, the body is in which kind of equilibrium? So if it is a static equilibrium, then what should be the condition? Can we say that F2 max is exactly equal to N1? Yes. F2 max is equal to how much? N1. And N2 plus F1 max is equal to how much? Mg. That's my equation or not? F2 max will be what? This is mu2 and this is mu1. So F2 max will be mu2 into N2. That will be exactly equal to how much? N1. Yes. And F1 max will be how much? F1 max is how much? Mu into mu1 into N1, isn't it? That is exactly equal to how much? Mg. So what I get as N1? N1 can be written as oh sorry. Can I write N2 as N1 by how much? Mu2. And this is how much? N2 plus mu1 into N1 is equal to how much? Mg. Apply this equation over there since it is in equilibrium. So N1 by mu2 plus mu1 by N mu1 in is equal to how much? Mg. And then you have the relation that n1 common, and I can write it as what? 1 plus mu2 mu1 divided by how much? Mu2 is equal to how much? Mg. So n1 is equal to how much? That's mg into, I think, mu2 divided 1 plus mu1 into, is that clear or not? Mhm. Is that clear? F max is equal to n1. Yeah. So basically what I got as relation, one thing, let me just check. N2. Now, if you just apply in this equation, what you get as, this is my N1. Replace it over here. What you get as N2 is equal to what? Mg by 1 plus mu1 and mu2 or not? So which option is correct? Option C. That if mu1 is not equal to 0, mu2 is not equal to 0, then N2 is equal to mg by 1 plus mu1 into mu2. Is that clear or not? I think Shreyas is saying C and D both are correct. Let me just check Shreyas. Topic 2. Topic 2. Yes, both are correct. Now you can replace mu1 value as 0. What you will get, you will see that n1 tan theta is equal to mg by 2. So both options are correct. What? Because no, it's saying as the option. If I just the question is which options are correct. So if I do not take mu1 and mu2 as not equal to 0, I'll get n2 as mg by 1 plus mu1 into mu2. Are you able to get me or not? Yeah. No. It can be multiple answers. It's an advanced question, right or not? Okay. Yeah. So both options are correct. C and D. आगे बढ़े. चलो. अब बताओ. ये वाले क्वेश्चन बताओ. काफी तगड़े क्वेश्चन है ये. This is, I think so. This is the friction. Two minutes time you have. Whoa, it's a nice question. Mhm. 'Think it's 8. नहीं सर थोड़ा सा गलत है सोचो. हाँ, there is no common acceleration. The bodies are not sliding, so that block A does not slide. Sorry, 1 minute. There will be something. What it is saying, you see the question. Both are the blocks, and I applied the force on the down. So question is, so that the block A does not slide over block B. It is the question is that. So find the condition. Like if the it does not say that both are at rest, it just says that A is at rest only. अच्छा इस क्वेश्चन की टेक्निक सोचे सोचे जरा कैसे बनता है ना. देखो पहले एक बात समझो. अगर ये ब्लॉक, पहले कॉन्सेप्ट समझते हैं, अप्रोच समझते हैं. व्हाट इज गोइंग टू बी द अप्रोच. ठीक. मान लो ये ब्लॉक ए है, ये ब्लॉक बी है ना. अब ब्लॉक बी के ऊपर हमने फोर्स लगा दिया. अगर तुम सोचो, अगर तुम बस में बैठते हो, अगर बस आगे जाती है तो तुम पीछे की ओर ढकेले जाते हो ना. तो इसका मतलब अगर पीछे अगर नीचे वाले को फोर्स एफ से ढकेला तो सिंपल सी बात है इस ब्लॉक ए के ऊपर एक पीछे की ओर सूडो फोर्स लगेगा। मान लो वो एफ पी है, कितना सूडो फोर्स कितना एफ पी। तो ब्लॉक ए की कंडीशन क्या है, पीछे जाने की। अच्छा इस जब ये पीछे जाने की कोशिश करेगा, yes, so frictional force between A and B will try to stop it. Yes. Now I applied the force F. What it is saying, the coefficient of friction between A and B is this. The maximum force F that can be applied on B horizontally so that the block A does not slide over block B. अच्छा अब एक सिंपल सी बात है, अगर मैंने ये मैक्सिमम फोर्स लगाया तो सोचो जरा, अब ध्यान से सोचो, ब्लॉक बी के नीचे वाला भी सरफेस कैसा है, रफ। तो एक फ्रिक्शन यहाँ पे भी लगेगा, दैट विल बी फ्रिक्शन बिटवीन बी एंड सरफेस। Yes, but does it says that the whole system will be at rest? No, I do not know. So let us consider that they have a common acceleration AC after this in such a way मतलब दोनों साथ मिलके दौड़ रहे हैं और एक ऐसा है बी पे रेस्ट पर है। Are you able to get me or not? Is that clear? देखो, अगर हमने F max लगाया, अगर F max लगाया such that A is rest on B, it does not says that both are at rest. Is that clear or not? If I apply F max, I know that simply that they will run. Let us see that what with what acceleration they will run. If it is if it can come as zero also, it will come as some positive value also. Is that clear or not? We do not know. Okay, that's what I'm saying. I'm just considering it because there is nothing written in the question. If they write it, it is. Let us see that. How do you know that? It's physics. It's physics, Risti. You do not know that whether it is at rest or not. We do not know. That's the answer. Okay. So if I just write the equation of that, then the pulling force for both of the blocks is just F max, isn't it? ओके एफ मैक्स। अच्छा अब ध्यान से देखो, तो दोनों के लिए सिंपल सी बात है, अगर ये एफ ए बी इस सरफेस के लिए आगे लगा है तो फोर्स फ्रिक्शनल फोर्स कांटेक्ट फोर्स होता है, तो एफ ए बी इसके लिए पीछे लगेगा, है कि नहीं? हाँ क्यों? क्यों? फ्रिक्शन है ना। फ्रिक्शन कौन सी फोर्स होती है, कांटेक्ट फोर्स, तो एक इक्वल एंड अपोजिट रिएक्शन होगा या नहीं होगा? ओके, यस, ओके। तो एफ ए बी आ गया तो इसके लिए कहाँ लगेगा, पीछे। यस, यस, टोटली टेंशन वाला केस है ना। तो इक्वेशन क्या आएगा, एफ मैक्स। तो ये एफ ए बी कैंसिल। अब ध्यान से सोचो, एफ मैक्स जो फ्रिक्शन इन दोनों को अपोज करेगी वही फ्रिक्शन मेरे को कंसिडर करना पड़ेगा, एफ बी एस। इज दिस क्लियर और नॉट? बिकॉज ऊपर वाली फ्रिक्शन तो कैंसिल हो जाएगी और ए जो है रेस्ट पर है, ठीक है। तो क्या आएगा, एफ बी अपोजिंग फोर्स क्या होगा, फ्रिक्शन बिटवीन बी एंड एस, that will make my both of the blocks MA plus MB to move with common acceleration AC. Are you able to get me or not? मेरी बात समझ में आई? तो इक्वेशन क्या है बचेगा, F मैक्स। अगर मैक्सिमम फोर्स लगा तो ये जो फ्रिक्शन भी लगेगा वो कैसा लगेगा, मैक्स ही लगेगा, है ना। तो मैक्सिमम फ्रिक्शन क्या होगा, म्यू इनटू नॉर्मल। अब ध्यान से सोचो, तो जो नीचे वाली सरफेस पे जो नॉर्मल होगी, दैट नॉर्मल विल बी नथिंग बट द सम ऑफ masses of A and B or not, consider it to be N2. So N2 will be what, Ma plus Mb into gravity g। और N1 की वैल्यू सिर्फ मास A के बराबर होगी, है कि नहीं? आर एबल टू गेट मी और नॉट? तो क्या आएगा, म्यू इनटू Ma, तो इज इक्वल टू Ma, सेफ है ना आंसर, एक्सेलरेशन AC, है ना। मेरी बात समझ में आई या नहीं आई? ठीक, इज दिस क्लियर? तो बस ये तुम्हारा इक्वेशन हो गया। अब ध्यान से सोचो जरा, तो म्यू की वैल्यू हमें पता है, तो हमारे पास इक्वेशन क्या आएगा, इसको मान लो एफ माइनस म्यू बिटवीन द टेबल एंड सरफेस 0.2। एम ए कितना है, ए और बी दोनों 1 + 3 4 kg, ग्रेविटी हो गया 10, इज इक्वल टू 4 इंटू कॉमन एक्सेलरेशन AC। AC की वैल्यू कितनी आई, 4 2 जा 8, f minus 8 by 4. ये इक्वेशन आया या नहीं आया? दिस इज माय फर्स्ट इक्वेशन. आर यू एबल टू गेट मी? अब ध्यान से सोचो, ब्लॉक ए रेस्ट पे है ना, तो उसके ऊपर स्यूडो फोर्स एक पीछे लग रहा है नहीं लग रहा? तो यस, सो फुल स्यूडो फोर्स मस्ट बी इक्वल टू f of ab. इज दैट क्लियर और नॉट? स्यूडो फोर्स क्या होता है? मास इनटू कॉमन एक्सेलरेशन. देखो अगर AC से चला तो इसके ऊपर स्यूडो फोर्स भी तो कॉमन एक्सेलरेशन AC से आएगा ना, क्योंकि B AC से चल रहा है. आर यू एबल टू गेट मी और नॉट? मेरी बात देखो ध्यान से समझो. तुमने फोर्स कहाँ लगाया? बी के ऊपर लगाया है ना. अब ध्यान से सोचो जरा, अगर हम बस में बैठे रहते हैं तो क्या हमारे ऊपर फोर्स नहीं लग रहा होता है? लग रहा होता है ना. क्यों लग रहा होता है? क्योंकि जो आगे गाड़ी जा रही है उसकी कॉमन एक्सेलरेशन AC है ना. भले वो गाड़ी हम दोनों को लेके चल रही है, लेकिन हमारे ऊपर एक स्यूडो फोर्स पीछे सीट पर चिपका के रखता है नहीं रखता? दैट विल बी मास ऑफ A इनटू कॉमन एक्सेलरेशन AC होगा, है कि नहीं? आर एबल टू गेट मी? बस बात खत्म. क्या मालूम चला? सिंपल सी बात है कि सर pseudo force must be equal to frictional force, and that will be exactly equal to uh, कितना लिखें? that will be mass into common acceleration AC मान लो, है ना. तो अब फ्रिक्शनल फोर्स है कितना तुम्हारे पास? एफ ऑफ ए भी क्या होगा? म्यू इनटू pseudo force mass of AC माने या mass of AC नहीं माने? हम्म, 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 हम्म. अगर ध्यान से सोचा जाए तो म्यू म्यू की वैल्यू कितनी है? 0.2. और ब्लॉक ए का मास कितना है? 1 kg. और ग्रेविटी कितना है? 10. तो ये कितना आ रहा है? 2 न्यूटन, है कि नहीं? मास ऑफ एसी लगाने की जरूरत ही नहीं है यार, इससे कॉम्प्लिकेट हो जाएगा. तो एफ ऑफ बी आराम से आ गया, सॉरी एफ सूडो फोर्स अपने आप को आराम से आ गया. कितना आया? 2 न्यूटन के बराबर आया, है कि नहीं? Is that clear? I just put it the frictional force value. Are you able to get me or not? Frictional force of AB will be what? Mu into normal one, है कि नहीं? इतना ही होगा ना. Normal one क्या होगा? Normal one will be equal to mass of A into gravity G. So you just put in that equation what you got, that FP is equal to 2 न्यूटन्स, है ना. अब ध्यान से सोचो जरा, जैसे ही तुम्हें 2 न्यूटन्स मिलेगा, ठीक है, तो ये अपन को क्या आया? अगर हम ध्यान से सोचें, 1 मिनट यार. हाँ, अगर हम ध्यान से सोचें तो ये जो एफ पी है दैट इज माई मास इनटू व्हाट? कॉमन एक्सेलरेशन इज और नॉट? सो दैट इज हाउ मच? 2 न्यूटन्स. मास कितना है अपन का? 1. तो कॉमन एक्सेलरेशन कितना है? 2 न्यूटन. सो बेसिकली कॉमन एक्सेलरेशन आया कितना? 2 न्यूटन. सो जस्ट रिप्लेस इट ओवर हियर. दैट इज 2 into 4 is equal plus 8 is equal to F max. Is that clear or not? तो F max की वैल्यू कितनी आई? 16 न्यूटन. Are you able to get me or not? Is that clear? The what is what the thing is, what will be the mistake that people will do? They will say that this F max is FP, but that is incorrect. Are you able to get me or not? या मेनी पीपल विल डू लाइक दैट. मैंने देखा है बहुत लोगों को करते हुए. जैसे पहले मैं भी करता था. मैं सोचता था कि इसके ऊपर जितना फोर्स लग रहा है इसके ऊपर भी पीछे सेम फोर्स लग जाएगा तो बॉडी तो रेस्ट में आ गई, है कि नहीं? ये स्लाइड नहीं करेगा. आर एबल टू गेट मी नॉट? बट दैट इज टोटली इनकरेक्ट बिकॉज या बिकॉज द मासेस आर टोटली डिफरेंट. आर एबल टू गेट मी नॉट? है ना. तो इसीलिए मैंने क्या लिखा कि जो भी इसकी एक्सेलरेशन होगी उसकी वैल्यू इस पे लगेगी विच विल बी m इनटू AC. तो यहाँ पे m इनटू AC इज इक्वल टू म्यू वन लगा दो तो तुम्हें क्या मिला? AC2. और पुट करो तो F max की वैल्यू आ गई कितनी अपन के पास? 12 सॉरी 16 न्यूटन. इज दैट क्लियर और नॉट? मजा आया? तो अपन को बस ये याद रखना, अपन को रिजोल्यूशन, जैसे अगर इसका एक और कॉन्सेप्ट बता ही देता हूँ. मान लो अगर दो ब्लॉक्स हैं, ठीक है, मैं सेपरेट करके दिखा रहा है ना, so that you can get understand this is A, this is B, and I applied the force on top of this. Okay, and I also said that both of them should move together. So once again, if they want to move together, they must have a common acceleration, isn't it? Yes. अगर ध्यान से सोचो तो अगर कॉमन एक्सेलरेशन इसी है, तुमने उसके ऊपर फोर्स लगाया, तो मास एम की टेंडेंसी क्या है, आगे जाने की, राइट की ओर जाने की है ना। तो फ्रिक्शन कहाँ लाएगा, बेसिकली पीछे फ्रिक्शन कहाँ लाएगा। तो इस एमबी के लिए फ्रिक्शन कहाँ लाएगा, आगे की ओर। आर यू एबल टू गेट मी और नॉट। और जो इसको क्या करेगा, बाइंड करके रखेगा, क्योंकि इसके पीछे क्या लगने वाला है, मास एमबी इनटू कॉमन एक्सेलरेशन एसी पीछे की ओर लगने वाला है। आर यू एबल टू गेट मी और नॉट। इज दैट क्लियर। ठीक है, अगर सरफेस में फ्रिक्शन आ गया तो वो अलग फ्रिक्शन हो जाएगा। मेरी बात समझ में आई या नहीं है। I'll take one class for the two bodies system, ठीक है, टू ब्लॉक या थ्री ब्लॉक सिस्टम के लिए ना तुम्हारी एक एक्स्ट्रा क्लास लगाऊंगा। मुझे लग रहा है तुम्हें लगाना पड़ेगा। इज दैट क्लियर। एक आधे घंटे का सेशन रखेंगे, उसमें कंप्लीट हो जाएगा, ठीक है। नाइस ना। चलो, ये क्वेश्चन, हाँ ये मेरा फेवरेट क्वेश्चन है। आई लव दिस क्वेश्चन टू मच। बोल रहे हैं पेंटर ऑफ मास 100 केजी इज रेजिंग हिमसेल्फ, वाओ। And the crate, such an arrangement is called as Boson's chair, in which he stands as shown. When he pulls the rope, the force exerted by him on the crate floor is 450 Newton. The crate weighs 25 kg. Then find the acceleration of the system and the tension in the rope. 100 kg wala person is already there, which is trying to pull the rope. There can be some persons which can be 100 kgs, got it or not. It's not hypothetical. I have seen many guys more than 100 kgs. Yes. It's an awesome question, basically. I'm telling you, this is really an awesome question. Yeah. Now you got the point. Acha, how to solve, how to approach these questions? First thing is that, okay? How to approach these questions? The first task is separate the carrot. Okay, take two blocks. Consider one as, yeah, carrot बोलते क्या इंग्लिश में इसको? ओके, अपन मैं तो कैरेट बोलता इसको, गोल्ड कैरेट। कैरेट, गोल्ड कैरेट भी तो होता है ना। And this is my mass, and this is man. So remember that how to approach this question is, this will never come in neat. They are saying that this is going to come in neat. Yes, some approach of this is going to come in neat, definitely. There was a question of acceleration like this, where a monkey is accelerating upwards. Okay, so the approach is same. Just first divide the two objects, two masses in a different way. First as great. Uh-huh. It's like a free body diagram. So crate and man. Is that clear? Okay. So first thing is there will be a weight of crate which will be mcg. Just that. And then there will be mass of man into gravity. So are you able to get me? Two weights are separated. First task was the weight of the two persons. Weight is separated. What else is left? There are tensions over here, isn't it? If this is tension T, this is also how much tension T. Are you able to get me or not? So for the crate also the tension is acting upwards. For the man also the tension is acting where? Upwards. Are you able to get me or not? But then is the twist. When he pulls the rope, the force exerted by him on the crate's floor is 450 Newton. So when man is trying to pull this rope, the man is applying on the crate a force of how much? 450 newtons. So there is an extra force on. Yeah, there is an applied force which is how much? 250 Newton. And then definitely, The crate will also apply. हाँ 450. Oh, okay. Sorry, my fault. This is 450. Then what will happen with the man? There will be a reaction on the man also or not? For that force, consider that reaction to be, what will be that reaction? Is it going to be same or different? Is it going to be same or different? First tell me that. श्रेयस, अरे एक बात बता, जब मैन ने इस क्रेट के ऊपर नीचे धक्का मारा तो फ्लोर से एक रिएक्शन आएगा ना? हाँ, तो क्या वो रिएक्शन इस फोर्स के बराबर ही होगा या अलग होगा? बताओ। ये बहुत ही अच्छा, बहुत ही मतलब बेस्ट लेवल चीज थिंकिंग करनी है इसमें। इज द रिएक्शन इज गोइंग टू बी सेम और डिफरेंट? Means the reaction by the floor will exactly be equal to 450 newtons or different? Think. I do not know. You have to tell me that. श्रेयस बोल रहा है सेम। अच्छा एक बात बताओ, जो मैन है क्या वो सरफेस को पेनिट्रेट कर दे रहा है? Is it penetrating? Tell me that. If it is not penetrating, then what will happen? The forces are gonna be same. Is that clear or not? So whenever the man is there, remember that the force is always going to be same. The man will have the same reaction by the surface as, 1 minute, as the, what is happening. Yeah, so that is also exactly equal to how much? 450. So this is my approach. Are you able to get me or not? You have to remember in that sense. ओके, तो पूछ रहे फाइंड द एक्सेलरेशन एंड द टेंशन इन द रोप। तो सिंपल सी बात है, अगर ध्यान से देखा जाए तो दोनों कहाँ जाएंगे? ऊपर एक्सेलरेशन ए के साथ ऊपर जाएंगे ना, कॉमन एक्सेलरेशन एसी के साथ है ना। तो इक्वेशन क्या आएगा? इसका इक्वेशन आएगा टी माइनस एफ माइनस एम सी जी इज इक्वल टू एम सी इंटू ए सी, और इसका इक्वेशन आएगा टी प्लस एफ ए फॉर एप्पल, बी फॉर बॉय, सी फॉर कैट, डी फॉर डॉग माइनस एम एम जी इज इक्वल टू एम एम इंटू कॉमन एक्सेलरेशन ए सी। आर एबल टू गेट मी? सॉल्व कर लो ना, इसको आंसर आ जाएगा। इसको मान लो माइनस, इसको मान लो ये माइनस है, ये भी माइनस, ये हो जाएगा प्लस, ये हो जाएगा माइनस, है कि नहीं? ताकि हम क्या कैंसिल करें? फोर्स को, ताकि हम टेंशन को कैंसिल कर सके। आर एबल टू गेट मी? क्योंकि फोर्स दिया हुआ है ना, तो क्या आ जाएगा? माइनस 450 तो दैट इज माइनस 900, और ये क्या हो जाएगा? प्लस है तो माइनस एम सी जी प्लस एम एम जी इज इक्वल टू एम सी माइनस एम एम इंटू कॉमन एक्सेलरेशन ए सी। पुट कर दोगे तो आंसर मिलेगा या नहीं मिलेगा? इज दैट क्लियर? ठीक है, जो मैं थोड़ा सा इधर लिखता हूँ वरना दिखेगा नहीं। सो व्हाट विल बी इक्वेशन? माइनस 900 माइनस mcc plus mmg is equal to mc minus mm into common acceleration AC. You apply this, you will get the answer or not. So when you get that common acceleration, applying any of the equations, you will get the value of tension. Are you able to get me? Acceleration is 2 meter per second square and tension will then come at 750 newtons. ठीक है? And tension will come as 750 newtons. Is that clear? मजा आया? Still there are how many questions? 1, 2, 3, 4, 5, 6, 7. Oh shit, 7 questions are still left. Okay. So we'll keep up this. How many questions we did? Almost 1, 2, 3, 4. We almost did 10 questions with the proper descriptions, isn't it? Okay, that's nice. That's nice. Okay. So we are stopping over here and then we'll meet on Wednesday, I think so, with those questions. Yeah, तब तक के लिए टाटा बाय बाय, सी यू।